Hello everyone. In this video, we provide some examples related to counting techniques. Let's take a look at the first example. A committee with a president, a vice president, a treasurer, and a secretary is being elected in the annual meeting. In how many ways can the officers be elected if there are 5 nominees for the position of president, 3 for the position of vice president, 2 for the position of treasurer, and 3 for the position of secretary? Here, the 4 positions can be regarded as 4 subsets. The position for the president, we have 5 nominees, 5 choices. Vice president, we have 3 choices. The treasurer, we have 2 choices. And the secretary, we have 3 choices. We can adopt the multiplicative rule, multiply the numbers together to obtain the number of ways these officers can be elected. So the number of ways is equals to 5 times 3 times 2 times 3, which is equals to 90. Let's take a look at a variation. In how many ways can the officers be elected if there are a total of 13 nominees for the 4 positions? The committee is formed with the first one being the president, followed by vice president, treasurer, and finally the secretary. Here, the order does matter. The first person being elected is the president. The second person being elected is the vice president, followed by the treasurer, and then the secretary positions. So again, we can regard these 4 positions as 4 different subsets. For the president position, we start with the 13 nominees. Once the first person is elected as president, for the vice president positions, we are left with 12 nominees. And then for the treasurer positions, we are left with 11 nominees. And then for the secretary positions, we have 10 nominees remaining. We can adopt the multiplicative rule, multiply these 4 numbers together to obtain the answer. Or we can regard this example as a permutation problem. Choose 4 out of 13, and order does matter. So the number of ways equals 13 by 12 by 11 by 10. Using permutation notation, we get 13p4. Upon calculation, we get 17,160 number of ways to elect the officers. Let's take a look at another variation of the problem. In how many ways can the officers be elected if there are a total of 13 nominees for the 4 positions? The 4 officers are selected from the 13 nominees at once, and they will then fill up the 4 positions among themselves. Here, the order a person is elected does not matter. So this is an example involving combinations. We choose 4 out of 13. Order does not matter. So the number of ways is 13c4, which is equal to 13 factorial divided by 4 factorial by 13 minus 4 factorial. Upon calculation, we get the answer 715. There are 715 ways the officers can be elected under this restriction. All right, so let's move on to another example. A committee of 3 people is to be chosen from 4 married couples. Find in how many ways this committee can be chosen if the 8 people are equally eligible. We have 4 couples, A, B, C, and D. So couple A, we have A1 and A2, couple B, B1, B2, and then C1, C2, and D1, D2. All the 8 people are equally eligible, so we can regard this 8 people as 8 individuals. So we only need to choose 3 people to be in the committee out of 8 people. Order does not matter. So the number of ways is 8C3. Upon calculation, we get 56. So there are 56 different ways the committee can be chosen if the 8 people are equally eligible. What if we impose a condition? In how many ways this committee can be chosen if a couple cannot both serve on the committee? So for every couple, only one person can be chosen to be included in the committee. How do we tackle this problem? So only one person can be included. So we will consider these 8 people as 4 units, one couple as 1 unit. We need to choose 3 people to be included in the committee. So we can choose out of these 4 couples. First, we choose 3 couples. So the number of ways to choose 3 couples out of 4 couples is 4C3, which is equals to 4. Once the 3 couples are selected, then for each couple, we choose 1 member. So for couple number 1, we have 2 choices. For couple number 2, we have 2 choices as well. And for couple number 3, we have 2 choices as well. So once the 3 couples are selected, there are altogether 2 by 2 by 2 equals to 8 ways to choose the 3 people, 1 from each couple. So we can regard this as 2 subsets. The first one, the first procedure is to select 3 couples out of 4 couples. And then the second stage, for every couple, we choose 1 out of 2. So there are altogether 4 ways to choose the 3 couples out of 4 couples, and there are 8 ways to choose 1 member within each couple to form a committee of 3. The number of ways in choosing 3 people out of the 4 married couples in this condition is equals to 4C3 multiplied by 8 equals to 4 by 8 equals to 32. So there are 32 ways to choose the committee, provided that a couple cannot both serve on the committee. Let's move on to the final example. In the classroom, there are 5 math students and 10 stat students. 3 student representatives are randomly selected from these 15 students. What is the probability that there are exactly 1 math and 2 STAT student representatives. In this question, we are asked about probability. But first, we need to do the counting. At the very beginning, we start with 15 students. We need to choose 3 out of these 15 students as representatives. So 15 choose 3. So there are altogether 15 C3 number of ways to choose the 3 student representatives. But we need to split these 15 students into math students and stat students. So out of these 15 students, there are 5 math students and 10 stat students. For the math student, we want to select exactly 1. So from the 5 math students, we choose 1. And for the 10 statistics student, we want to select exactly 2. So there are altogether for the math student, there are 5 C1 number of ways. And for choosing the 2 stat student, there are 10 C2 number of ways. The math and the stat student can be regarded as 2 different subsets. So we can adopt the multiplicative rule to calculate in how many ways we can choose exactly 1 math student and 2 stat student as representatives. Here, let event A be the selection of 1 math and 2 stat students. So the probability of A is equals to 5C1 times 10C2 divided by 15C3. The number of ways we can choose exactly 1 math and 2 stat students is equals to 5C1 times 10C2. These are the total number of ways corresponds to event A, the selection of exactly 1 math and 2 stat students. And then in the denominator, 15C3. This is the total number of ways we can choose 3 students out of 15 students. So the probability of this event A is equals to these expressions. 5C1 is equals to 5, 10C2 equals 45, and 15C3 equals 455. Upon calculation, we get 0.4945. This is the probability of selecting exactly 1 math and 2 stat students out of the 15 students in the class. So I hope these examples can help you to get more familiar with the counting technique. Thank you for watching, and in the next video, we will talk about conditional probability.